In this video, we're going to do 10.02 update battery. So I have it downloaded and open up in Racket. So let's go over the problem. Finish the uncompleted steps X of data design above for battery and evcar. So we see that the data description is done for both of these, right? We had to do 1B, 3, and 4. So let's review the battery structure really quickly. So battery is a defined struct with an ID being the number and charge also being a number. And the ID is a unique port number the car will have, right? That will check if it's compatible with other batteries, right? Charge is the percent charge of the battery. Okay. So let's go and do 1B, 3, and 4. Pause the video and try to work on this on your own. Avoid spoilers in 3, 2, and 1. All right, so I'm assuming that you guys took a good swing at it. So now let's go over it together. So 1B, we have to write all the access signatures. So battery dash ID consumes a number. Well, it consumes a battery, my bad, and produces a number. That's what I meant. And likewise, battery dash charge consumes a battery and produces a number. Okay, so that's that done. The access signatures, easy peasy. Let's move on to the data examples. All right, let's come up with some example batteries here. So define battery Tesla, that's what we'll name it, full. We'll say bat tes full. So bat Tesla full is a make battery. And we'll say the ID is, I don't know, 4292, okay? And then the charge is 100, okay? Likewise, let's do one when it's half, right? What happens when it's half? A half battery example. And we'll do another example with batteries with different IDs, right? This time, BYD is the Chinese competitor. That's not allowed in the US. Part ID, we'll just come up with, 6612. All right. So this is a full BYD battery. This is a half one. All good. Okay, so those are good enough examples. Easy peasy. All right, next is a function template that processes this data. So let's just come up with that. Parity-temp is going to be consuming a battery, and we don't know what it'll reduce yet. We're just laying out a good foundation. Define battery-temp. Consumes a battery, let's call it BAT, all right? Or maybe BT. Yeah, BT for the input variable. And then we'll take it apart. So battery-ID, we probably want to use the ID. And functions that use this template also probably want to use the charge as well. Okay. And that is that done. So gonna mark myself off for that. Like so. Okay. So now let's move on to evcar. So evcar is a structure and it has a string, which is the name, and bats, which is battery. Okay. And here's the interpretation. Name is the name brand of the car, and bat is a reference to a battery structure. Okay. So try to do 1B, 3, and 4 on your own. I'm gonna go over spoilers in 3, 2, and 1. All right, so I'm assuming that you guys took a good swing at it. So now let's go over it together. All right, so 1B, if using define struct, write all the access signatures for evcar. So by virtue of that define struct, we get evcar-name, which consumes an evcar and produces a string, and evcar-bat that consumes an evcar and produces the battery. Okay, so that is define struct signatures done, right? So next are some data examples. So let's come up with some cars here. Define, make evcar, say Tesla, and we'll give it the half battery. So bat Tesla half. All right. Do another car. So I forgot to name this variable. All right. And then likewise, we'll do one. Define BYD is a make evcar where the name is BYD, and we'll give it its battery. All right. Half, like so. Okie dokie. So those are the examples done. All right, next is a function template that processes this data. All right, so we're going to make an evcar-temp, consumes an evcar, and produces, we don't know yet because it's just a template. So functions that use this template, wait, should take an evcar, let's just name it ev as the input variable. And likewise, we want to take apart the ev parts for the functions that use this. So evcar name, ev, and evcar battery of the given ev. And ding ding ding, this is a reference to a battery structure. So likewise, you probably want to reference a helper function to process batteries because it'll help us simplify writing the functions. Okie dokie, so that is done. So there we go. Okay. So now let's move on to problem B. I'm going to scroll down here because we're going to write some functions. All right, so problem B, in some parts of China, there are EV battery swapping stations. The battery swap should only happen if the ID number of the current car's battery and the new battery matches, and if the new battery has more charge than the one being replaced, right? Yeah, because it doesn't make sense, right? Why would you want to go to an EV car battery swapping station that gives you a lower charge battery rather than the new charge, right? All right. So write a function update battery that consumes an EV car and a battery and produces the car with the potentially replaced battery. And they gave us the signature here. Okie dokie. So pause the video and try to do these steps on your own. I will go over spoilers in 3, 2, and 1. All right, so I'm assuming that you guys got a good swing at it. So now let's go over it together. So here is the signature. Next is the purpose. So it replaces the battery of the EV car if it is of the same ID and has more charge, right? Replace the battery of the EV car with the new given battery only. All right, so this is that new given battery only if its ID, only if it's of the same ID and has more charge. Okay, so hopefully that flushed out what this should do in our minds. All right, on paper now. Okay, so signature, purpose, stub. So let's stub this out. Define update battery. Update battery is going to be a function that consumes an EV car. So we named that input variable EV, and I forgot what we called the battery one. It's called BT. All right, just staying consistent here. And it should produce an EV car. Let's just spit out the EV car that we're given to run some examples. Let's do some examples here. So check, expect. We're going to do update battery. All right, so we have a Tesla up here, right? And it's at half battery. So if we give it a battery, if we give it a full Tesla battery that has the same ID, right? Like so, then it should be replaced, right? So we should produce an EV car, make EV car such that the brand name stays exactly the same. So we're going to say Tesla, right? So the brand name stays the same, but the battery gets replaced, right? The half battery gets replaced with a full battery, like so. Okay, let's do that for the BYD case as well. So check, expect, update battery. We have a BYD, and then we're gonna try to load in, which is at half battery, right? And we're gonna give it a full battery, right? Like so. And this should produce an EV car with the same brand name and now the full battery. All right, full. Okie dokie. All right, let's do one more test for good measure. What happens if, okay, for the Tesla, right? What happens if we try to put a BYD battery in the Tesla, right? So where is our BYD battery? We can give it half or full, it doesn't matter. We'll try to give it a full BYD battery, right? Well, it can't do that, right? Because the IDs have to be the same and they're not compatible right over here, right? The ID is 4292 of Tesla batteries, and likewise with this, it's 6612 for BYD batteries, all right? So those are usually long barcode numbers, but I shortened it for good measure for easy typing here. So what should happen if we're given a Tesla here, right, with half battery, and we try to replace it with a full BYD battery, right? It shouldn't do that replacement. So it should stay exactly the same. Okay, so those should be enough examples. Let's just check ourselves off. All right, so there we go. So we did the signature purpose stub. Examples are done. Template, let's just do that now. Let me run it against the stub first. We get some mismatches, right? This Tesla with this battery is not replaced with the 100% battery just yet, right? So updating this Tesla that has a half battery with a full battery should produce a Tesla with a full battery. Okie dokie. So they still run, but we're good. So let's grab a template that consumes an evcar like so. I'm going to comment the stub out. And there. Takes in 2 arguments though, the EV and a battery. Okay. Now, I'm gonna mark myself done for that. Template is done. All right. Now let's do for code the body. So pause the video and hopefully this should be all the mental scaffolding needed to write the solution. I'm gonna go for spoilers in 3, 2, and 1. All right, so I'm gonna assume that you took a good swing at it. So let's go over it together. So we have to code the body of this function, update battery. All right, so we know looking at the signature, we have to produce an evcar, and let's just do that. Make evcar. All right, the name stays the same when we update the battery, right? Nothing about the name changes, so we can just leave it alone. But what about this one right here, right? Battery temp. Well, if we read the problem statement, replace the battery of the evcar with a new one only if it has the same charge and the same ID, right? So what we kind of need to do here is to decide which battery to put in, right? And you can name this replace battery or whatever, but I'm going to choose decide battery. There's probably a better name that you can come up with this, and yeah, but this is what I'm going to name it. Okay. So we're going to put the decide between the evcar's battery and the battery that we're given, like so. BT. Okay. And we can rename BT to be like, I don't know, nbat. New bat. All right. That kind of makes it more, you know, the new incoming battery. So nbat. The incoming battery that we're trying to replace it with. That hopefully makes more sense. It's a better naming scheme. All right. So now we have to write the decide battery function because it's not defined, right? Decide battery. It's going to consume 2 batteries, right? Because evcar dash battery gets the battery out of the evcar, right? Evcar dash bat. All right. So, whoops, I kind of wrote this wrong. The template's wrong, right? It should be ev dash bat, right? That's the field name, not battery. All right. Battery is the type here. So, whoops, that's all good. All right. So it consumes, so this, right, reduces a battery, and this, we're getting an incoming battery to update. So this function consumes 2 batteries and produces a battery, right? Because this make ev takes in as its first argument a string, the brand name, and the battery itself, and this function decides which battery it is. All right, so pause the video and try to do the function steps for decide battery. All right, I'm gonna go for spoilers in 3, 2, and 1. Okay, so I'm assuming that you took a good swing at it. So let's do the purpose statement for this. So produce the second given battery if it has more charge than the first and is of the same ID. All right, signature purpose. Let's stub this out. So define decide battery. It's going to take in 2 batteries, so we call it BT and BT2. All right. And then it's going to produce a battery, so we'll just pick either one for the stub. Okay. So that is signature purpose stub done. So let's just mark ourselves done for that. All right. Next are some examples. So decide between check expect decide battery, right? Decide battery. of the Tesla half battery, and the Tesla full battery. All right, so it should produce the second one if they're the same ID. Oh, it auto-completed the wrong one. All right, full. Right, so it should produce the second one if they're the same ID. So they are the same ID. They're both Tesla batteries. And which one has more charge? Well, it's the full one, right? So it should produce the second given one, like so. And let's just do a few more for good measure. So what happens if the order is swapped, right? Like we're given the half battery as the second argument to decide battery, right? Well, we should still produce the full battery according to this purpose statement, right? Produce the second given battery if it has more charge than the first and is of the same ID. So this same ID, but this one, the first one has more charge. So we're not going to produce the second battery. We're going to produce the first one. All right. Let's do one more for good measure. I'm going to copy and paste this down. And what happens? All right. Decide between a battery, Tesla full, and we'll do a BYD one, right? So battery BYD full. All right. What happens in this case? Well, we want to produce the second given battery, the BYD one, only if it is of the same ID and it has more charge, right? So this doesn't really matter in the case that they don't have the same ID, so we should produce the first one, like so. Okay. So it doesn't really matter about what their charge is, but let's just do one for the charge. So replace a BYD half battery, Tesla half battery, with a BYD full battery. It should still produce the half battery, right? You can't replace it. They're incompatible. All right, so that's a good amount of examples. Let's just run the stub against the examples. We get a bunch of mismatches, but it's all good. Okay, so gonna comment the stub out. We finished our examples, and now we're gonna grab a template that consumes a battery. It has starter code to kickstart our development, like so. Okie dokie. All right, so decide battery, takes in 2 arguments this time, BT, BT2. Likewise, we want to destructure, take apart the second battery as well as the first one. All right, so this is some good scaffolding, and we're done with templating all we need. We laid out all the pieces. All right, so now it's time for the hardest part, coding the body. So pause the video. Hopefully this should be all the mental scaffolding needed to solve the problem. I'm gonna go with spoilers in 3, 2, and 1. All right, so I'm assuming that you took a good swing at it. So now let's go over it together. All right, so if we look at the purpose statement, right? Produce the second given battery if it has more charge than the first, right? So we need an if here, all right? And if has a condition, 3 parts, right? The condition in the true and false case, right? So we need to compare the IDs, and IDs are numbers, right? So we're going to have to use equal. So if they're the same ID, right? So that's what the purpose statement says. If they're the same ID, right? If they're of the same ID, right? Then we want to, and what? And it has more charge, right? So we have to do an and here. Wrap this around, and I'm going to give myself some more space. And now we have to compare the charges, right? So, like so. So let's stick the charges close together. The battery charges of both the 2 batteries, like so. All right. Okay. So produce the second battery if it has more charge, right? So the second battery here has to have more charge, like so. So battery, if the first given battery is less than the second given battery. All right. Okay, so this, right, is that condition from the purpose statement. So if this is true, we can produce the second given battery. Otherwise, we'll just produce the first given battery. So if we run this, it should pass our test, and so they do. So that is the code body done for all of it. Test review and refactor. It looks pretty good. You could rename decide battery to, like, you know, decide, you know, more charge battery or something. I don't know. Can't come up with a name right now. Anywho, that is mostly it. So I challenge you, right, as a funny exercise to write this function without using a helper, right? Write update battery without using a decide battery helper, all right? And you'll see how messy it sort of gets. Anyways, let's just submit this to hand-in, right? Select the slot, hand it in, and check your score on the website. All right. And that is about it for this one, and I will catch you in the next one.